Hello everybody, let's take a look at this quadratic algebraic inequality. 3x squared minus 11x is less than 4. Now notice it's less than, strictly less than, not less than or equal to. This will be important a bit later. So let's just get rid of, let's get 0 on the right hand side. So let's subtract 4 from both sides. So we end up with 3x squared minus 11x minus 4, and if we do it on the other side, 4 minus 4 is 0. So this is our inequality. And then when dealing with inequalities, we want to get the critical values. So to get the critical values, we have to solve this as an equation. So I'm going to write this out. Solve as an equation. So equation, solve as an equation to find critical values. So as an equation, this is 3x squared minus 11x minus 4 is equal to 0. So this is in equation form. So we're going to get two solutions for x because it is quadratic. And we can immediately just use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac. All that in under the square root divided by 2a. But I don't want to use the quadratic formula. We want to do this more traditionally using factorization. So what we need to see here is that this is not, the easiest. So you need to sometimes practice these type of problems. So to factorize this quadratic without using the quadratic formula, we need to take into account that a quadratic polynomial can be expressed as the product of two linear polynomials. Now inside this bracket, we're going to multiply out to get this quadratic here. So we see the coefficient of x squared is 3. Now 3 is a prime number, so the factors of 3 are just 1 and 3, so 1 times 3. And the constant coefficient, the one that doesn't have an x, which is in this case negative 4. Negative 4 has factors of, well, 1 times negative 4, I suppose. Negative 1 times 4. And then 2 times negative 2. So let's write the factors of 3. So we got 3 and 1. And then we're going to do some form of cross multiplication here. So let's try the different combinations. So we're going to try 1 and negative 4. And then over here we're going to try negative 1 and 4, let's say. And then the third one we'll try will be 3 and 1. And then 2 and negative 2. It doesn't matter which one I make 2. In fact, it does matter, so let me do the other option as well. Let's make this one 2 and negative 2. So I don't know if this is the method we used to use those years. So we're going to say 3 times negative 4 gives us negative 12. And then 1 times 1 gives us positive 1, and this is negative 11. Now let's do the same here. 3 times positive is 12. 1 times negative 1 is negative 1, and this gives us positive 11. And then we have 3 times 2 is 6. 1 times negative 2 is negative 2. This gives us 4. And here we have 3 times negative 2 is negative 6. And 1 times 2 is positive 2. This gives us negative 4. So the one we want is negative 11. Because that's our middle term. That's the coefficient of our middle term in the quadratic equation. So we want the combination where 3 multiplies with negative 4 and 1 multiplies with 1. So inside our linear bracket here. Let's write it again from scratch. So we got 3x squared minus 11x minus 4 is equal to 0. In our little product of brackets here, we're going to have 3x and x, and from what we saw above, we need the 3 to multiply by a negative 4. So the negative 4 is in this bracket, and we need it the other one to be a positive 1. This comes from the way we expand. We're going to say, and we can quickly test it. Let me write test actually. Let's just test it. I mean 3x times x is 3x squared. 3x times negative 4 is negative 12x. Positive 1 times x, positive 1x. Positive 1 times negative 4, negative 4. And if we simplify here, because we got like terms, we end up with 3x squared minus 11x minus 4. So this is indeed correct. So these are our factors. So we've got 3x plus 1 is equal to 0, and we've got x minus 4 is equal to 0. So from here we can actually get the critical values here. So 3x plus 1 is equal to 0 implies what? We subtract 1 from both sides, we have 3x is negative 1, and that means x is negative 1 over 3. And on this side here, it's just x is equal to 4. So our critical values, are simply x is negative 1 over 3 and x is 4. So what we do now is we draw a number line, a lovely horizontal line, the x-axis, and let's mark out these values. So this will be negative a third, and this will be 4. And now we need to consider 3 intervals. So the first interval is everything here to the left of negative a third. Let's call that I1 for interval 1. And then, now you must remember something. Earlier I said that it's just strictly less than. Our inequality is strictly less than, not less than or equal to. So we don't include the critical values. So normally what we'll do is we'll draw an open circle on these critical values. So it means we do not include these values. And then interval 2 is the one that's in between these values. So this is I2. And then the last interval, which we'll just call I3, is everything to the right of 4. So if we write this more formally, I1 is everything less than negative a third. So everything as in all the way to negative infinity up to negative a third, but not including. So not including means we put a round bracket. And with infinity we always have a round bracket because we never include infinity. And then for I2, our interval is not including a third, negative a third, and it goes from negative a third to 4, also not including 4. And then lastly I3 is everything to the right of 4, so it's 4 all the way to positive infinity, but again not including and not including. So what we normally do is you just pick random values from each interval and see if they satisfy the inequality. So from I1 we can pick any number that's in this interval. That's from negative infinity to negative a third. So let's just pick negative 1. Because to make life easy, we just pick an easy value. And let's go back to our inequality. Our inequality doesn't matter which way we write it in, but let's just write it with 0 on the right hand side. So our inequality is 3x squared, so in this case it will be 3 times negative 1 squared minus 11x, which is minus 11 times negative 1, and then minus 4. And what is this equal to? So negative 1 squared is just 1. 3 times 1 is just 3. Negative 11 times negative 1 is positive 11. So we've got 3 plus 11 is 14. 14 minus 4 is 10. Is 10 less than 0? Certainly not. So this interval does not work. Let's try I2. Let's pick any number in this interval. We can pick 0. Again, it's an easy example. So 3 times 0 squared minus 11 times 0 minus 4. So 0 times anything is 0, so those guys are all 0, which just end up with negative 4. Is negative 4 less than 0? Yes. So this is very good. And let's just, for good measure, let's do one from I3. I'll just pick the number 5, it's fine. Let's see what we have here. 3 times 5 squared minus 11 times 5 minus 4. 5 squared is 25. 3 times 25 is 75. 75 minus 55 is 20, because 11 times 5 is 55. 20 minus 4 is 16. Is this less than 0? No, it is not less than 0. So I3 is also not valid. So only I2 is valid. So we can just say, therefore, x resides or lives inside the interval. In the interval, resides in the interval I2. So you can just say, therefore, x is an element of negative a third to 4, and of course not including. So that is why we use the round bracket, and this should be valid. This is indeed the correct answer. Alright, thank you guys, bye bye.